Okay, so today we are going to begin working with systems of equations. And system of equations is just basically two different equations that we're looking for what the solution is. So let me give you a real life example. So you're looking for a rental car, right? Because you're going on vacation. And one place charges a little bit more per day, but a little bit less per mile. And the other charges a little bit more per mile, but a little bit less per day. And you try and figure out, okay, what is the better deal? So that's a real life scenario where we would use these. But before we get to solving them algebraically, I want to draw a graph, all right? And a graph, it's really important that you get this concept. A graph is a picture of every single solution to an equation. So for example, when we have the top equation, 1/2 x plus 4, there are a lot of x and y combinations that you can put in there. For example, if you put in 2 for x, then the answer for y would be 5. If you put in 6 for x, then the answer for y would be 7. If you put 10 in for x, the answer would be 9. And so there are literally an unlimited number of solutions that we could put in. And instead of writing down all of those solutions, what we do is we just draw a line, because a line is a picture of every single solution to an equation. So let's look at the top equation, 1/2 x plus 4, and I'm just going to draw a picture of that. And we know how this works. The y-intercept is positive 4, so I'm going to go up to 4 on the y-axis. And then our slope is 1/2, which means we go up 1 over 2, up 1 over 2, up 1 over 2, and we can just draw this line. So instead of writing out every single solution to it, we can just draw a picture of it, all right? So that's the red line there. Now, I'm going to change the color here just so that we can make the point a little bit better. The next equation, let's draw all the solutions to this. Y equals -1/4 x plus 6. So the y-intercept is positive 6, and the slope is down 1 over 4. Oh, you know what? I wanted to change this. I'm going to change this a little bit to -1/2 x plus 6. All right. I made a mistake as I did this, and it's going to come out a lot better if I go 1/2. So -1/2 x plus 6. So I went up 6, and then I went down 1 and over 2, down 1 and over 2, down 1 and over 2, and drawing the line. So the blue line is a picture of every single solution to that blue equation. The red line is a picture of every single solution to the red equation. And here's what I want to know. Is there a solution that works for both of these? Well, yeah, it is. The blue is all the blue answers. The red line is all the red answers. So where is the spot that is both red and blue? It's right there, right in the middle. Right where they cross is the solution, and that is the point 2, 1, 2, and then 1, 2, 3, 4, 5, 2, 5. That is the solution to this system of equations. So what that means is, if you put the point 2, 5 into that top equation, it's going to work. 1/2 times 2 is 1, plus 4 is 5. So 2, 5 works up there. If you put 2, 5 into the second equation, put 2 in for x, -1/2 times 2 is -1, plus 6 is 5. So both equations, 2, 5 works. And that is actually the only point, the only solution that's going to work for both of those. Let's do another one. Now, this is going to be a special situation, because I think we've got it that wherever those lines cross, that's going to be the solution. All the solutions to one equation, all the solutions to the other equation. So the solution to the system is wherever those lines cross, right in the middle. So let's graph this. I'm going to graph the top one first. Y equals 1/2 x plus 4. So I'm going to go up 4. It's my y-intercept, and then up 1 over 2. And we actually did this one last time. I just reused this first equation, and that is the line. So that is a picture of all the solutions to that top equation. Now, let's do a picture of all the solutions to the bottom one. Let's draw that line. So the y-intercept is -6, so I'll go down 6. The slope is 1/2, up 1 over 2, up 1 over 2, up 1 over 2. And as I draw this line, that's what I get. Okay, now look at this. Remember, the solution is where they cross, but what I see is two lines that look like train tracks. They're parallel lines. They never will cross. And so if they never cross, if none of those solutions are ever the same, that means this system of equations does not have any solutions. It does not matter what number you put in for x or y. You could try every single number in the entire world, and it would never work out. Okay, this one has no solutions. So this was a special one. And notice what we have here. We have the slopes that are equal. 1/2 in both of those. The slopes that are equal and different y-intercepts. Okay, that's kind of how we can tell that it's going to be no solutions. All right, let's look at this one. First, I'm going to graph the top one, and I'll just kind of color this blue. 2x minus 4. So let's just graph this. And then up 2 over 1, that's the slope. Slope of 2 means up 2 over 1. Whoops, I'm getting a little bit off there. That's pretty good. All right, so that's the blue one. Now let's graph the red one. And remember, this is just a picture of every single solution. Now the red one, this is written in standard form, so let's graph it using the intercepts. First of all, let's find the x-intercept. So we ignore y because that's 0. And if we just solve this for x, divide the 2 over, we would see x equals 2. Right there. Okay. Now let's find the y-intercept. So that means the x is 0. If we solve this, that's -1 times y. So divide the -1 over to the 4. And y is going to be -4. So if we come down to -4 right here, we've got 2 points. And if we've got 2 points, that's really all we need if we're drawing a straight line. So drawing the straight line right through there, we see that it is exactly the same line. All right? So where is a solution both red and blue? Well, it looks like there's one right there. And also right there. Right there's another one. Right there's another one. Right there's another one. And I bet you're wondering how long I'm going to keep doing that. Because you see, it's all over. That entire line, both red and blue, same place. Okay? Now, just an aside, some people would call this all real numbers. It's not all real numbers. And let me show you why. Let me show you a solution that is not or let me show you a point that's not a part of this solution. That point right there. That's not a part of this solution. So it's not all real numbers. But what we do have is kind of similar to that. We have infinitely many solutions. Infinitely many. All along that line. Everywhere on that line, there are solutions. So when it looks like this, it's infinitely many solutions. If we back up right here, this is no solutions. Those two never cross. And if we come back up here, we have one solution right where they cross, right at that intersection at the 0.25. Okay? I know you got it. Good luck.